Habarigani, welcome back to All This Math. This is Professor Parker. Here we are on the last day of Kwanzaa. Hopefully you watched all the videos from the previous 6 days of Kwanzaa. Here we are on the last day, which is Imani, which means faith. Shout out and rest in peace to my little brother, Kamal. Imani was his middle name. Um, yeah, I wanted to say that since that was his middle name. Wanted to shout him out on here. But how does this relate to math? How does faith relate to math? So when I think of faith and I think of mathematics, I think about how when we approach a math problem, you got to have some skills and you got to have some understanding and you got to have some ability, but you also got to have faith that you'll be able to arrive at the answer to the question or the solution to the problem. You got to have some faith. What a lot of people lack is faith. A lot of people lack skill set, right? So they need, to be taught how to do things, and they also need to practice on a regular and consistent basis, right? So the problems will become easier and easier as they see them. But a lot of people just lack the faith that they will be able to get to the answer, right? So you got to have a skill set, but you also got to have faith that your skill set will enable you to arrive at the answer. Similar to how in the black community, we got to have faith that we'll be able to solve our problems. And as the late Jacob Carruthers would often say, get out of the mess that we're in as a people. All right. So what I've done is I threw this problem up here, and this problem might be intimidating to a lot of people. Like I might look at this and get a little shook a little bit when I see a problem like this. I got variables and exponents, and then not even just an exponent, but an exponent expression like x plus 2, and then 2 minus x on the other side of the equal sign. All right. But if you got faith that you know how to do this, then you'll be able to figure it out. So look, this is what I'm going to do. I'm trying to solve for x. My instructions are to solve, right? First, read the instructions. What you supposed to do, Kill? Solve, right? So we're trying to solve for x over here and over here, right? And they got to have the same value. So what I want to do is I want to get those variables out of the exponents, right? I'm going to get them out of the exponents. So the way I do that is I do the opposite operation. The opposite of an exponent is a logarithm, or the opposite, if something is in exponential form, I should say, we apply a logarithm to it. So we basically would rewrite this like this. I'm going to put log in front, and then I'm going to have 3 log of 3 to the x plus 2 power. I'm going to do it on both sides of the equation. Then I'm going to have log of 4 to the 2 minus x power. Now, what does that enable me to do? What's the purpose of doing that, right? See, there's Nia, purpose, right? What's the purpose of doing that? The purpose of doing that is so I could use one of my logarithmic properties, and I could take this exponent and I could slide it to the front and make it a coefficient. And I could take this exponent, slide it to the front and make it a coefficient. So it's going to end up looking like this. Matter of fact, let me get a different color. So we're going to have x plus 2. We're going to slide them to the front like that. And then the 2 minus x, we're going to slide them to the front like that. Right? So now it's going to be in the next step, you're going to see what it's going to look like, right? It's going to be like this, right? We're going to have x plus 2, and I'm going to put it in parentheses, times the log of 3. And I can do that because that's one of the logarithmic properties. I could do that. That's one of the logarithmic properties. I'm going to do the same thing over here. 2 minus x times the log of 4. All right, so now look what I got. X plus 2 times log of 3 equals 2 minus x times the log of 4. Now, again, my ultimate goal is to solve for x, this x and this x. So at some point, I want to combine this expression with that expression, or combine all the x terms on one side of the equation, right? And then I'm going to be dealing with algebra. I'm going to be dealing with straight algebra. Now, right now, I'm going to start applying some algebraic properties. I'm taking it back to Algebra 1 now, right? You might see a question like this in an Algebra 2 course or a pre-calculus course. But now, since I've begun to simplify it, and I already used the logarithmic property, right, to move the exponents to the front and make them coefficients, now I'm using Algebra 1 properties. So now what I'm going to do is I'm going to get rid of this log 3. So how do I do that? Log 3 is being multiplied by x plus 2. So the opposite of multiplication, of course, is division. So I'm going to divide to get rid of this log 3. Because I want to get the x plus 2 by itself. If you're wondering, why am I getting rid of log 3? That's why. So I can get the x plus 2 by itself. But then you might say, well, why you ain't get rid of the log 4 so you can get the 2 minus x by itself? Well, I could have did that. That was another option. I could have definitely did that. But remember, I'm trying to have my x's on the left-hand side, not on the right-hand side. So this eventually, I want to bring this x from the right-hand side over to the left side ultimately anyway. So I'm going to do divide by log 3. So this is the same. This is something divided by itself. That's going to equal 1 anyway. So then I'm going to have x plus 2 on the left by itself is equal to 2 minus x. And now I'm going to get my calculator out, right? My trusty little TI-30. And I'm going to do log 4 divided by log 3. So I type in 4, then I hit the log button. And that's going to give me point. And I'm going to round it to 4 decimal places just to be on the safe side. Just so I'm like precise enough. So I get 0.6021 if I round it to 4 decimal places. Then I'm going to do log 3. I had faith. I had faith that I was going to be able to jog my memory and remember, like, oh, okay, these are the rules that I need to apply to figure this out. We're not done yet, but I just wanted to throw that out there. And then I'm going to have 0.4771, right? And then on the left-hand side, I got x plus 2 is equal to the quantity of 2 minus x. Now I got to do division. Because I want one single decimal. So 0.6021 divided by 0.4771, 1.262. 1.262 is what I got when I did that. So now we straight algebra with it. Now it's straight algebra. So I'm gonna distribute this 1.262 to the 2 and the negative x, the 2 and the negative x, the 2 and the negative x. So I got x plus 2 is equal to 1.262 times 2, which is 2.524. 2.524, just 2 times 1.262. Distributive property. The distributive property is your friend. Distributive property. And then I'm going to do the x times 1.262, and that's a negative x. So that's going to be minus 1.262x. Now I got an x on the left side. I got an x on the right side. So what I'm going to do is I want the x's on the same side. That was my ultimate goal, right? So I'm going to add 1.262x on the right side. I'm going to add 1.262x on the left side. These are going to cancel out. And then that's going to be 1x plus 1.262x is going to be 2.262x plus 2 is equal to 2.524. Now I'm running out of space down here, so I'm about to slide up here. So now I got 2.262x plus 2 is equal to 2.524. I'm trying to get the x term by itself. So let me subtract 2 on the left side, subtract 2 on the right side. 2 minus 2 is 0. So now I got 2.262x is equal to 0.524, because 2.524 minus 2 leaves us with 0.524. How do we get x by itself? Division, because this is multiplication. 2.262 times the variable x. The opposite of multiplication is division. So we're going to divide 2.262 on the left side and then 2.262 on the right side. So we got that. Then we got x equals. And then we got, so now I'm back to the calculator with it. 0.524. Now we about to find out what x is. Divided by 2.262 equals 0.2317. 0.2317. That's x. I just solved for x. But look, what if we want to check our work to make sure? Make sure it's right. Plug the values into the original equation and see if we get a true statement. Math is all about finding out the truth. We want to know if that's the truth. If it gives you a true statement, that means it's a correct answer. Correct answers give you true statements. Incorrect answers give you lies. All right. So let's check our work. switch up the color. So 3 to the 0.2317 plus 2 power, we're saying is equal to 4 to the 2 minus 0.2317 power. All right. So this is going to become 3 to the 2.2317 power. And then over here, we got 4. That's 2 minus. I need a calculator for that. I could figure it out, but it's more efficient right now to use a calculator for this. 2 minus, as much as as hard as I be going about people not using calculators, I don't know if this is the time. So 4 to the 1.7683 power. So now I'm gonna simplify this. I'm gonna simplify this, and I'm gonna simplify this. And we're gonna see if they equal. If they equal, that means this is a correct answer. So I'm gonna do this. I'm gonna do 3, hit the Y to the X button, and then 2.2317 is 11.6089. All right, that's that. That's the left side, 11.6089. What about the right side? 4, hit the Y to the X button, and then 1.7683 equals 11.60. Now, it's not the exact same thing. I get on the right side 11.6044, right? Now, before you think, oh, well, it's not the exact same thing, so that means the answer is wrong. It's not wrong, it's close enough. The reason that it's off a little bit is because of rounding. I rounded right here, right? I rounded, let me see. Where else did I round? Yeah, I just rounded. Once I rounded right here, I rounded to 0.6021. I rounded to 0.4771. When I divided, I rounded that, right? If I had not rounded, then these values would be closer to being exactly the same, but they basically are. Because look, what if I round them off? 11.6 on the, if I rounded to one decimal place, I got 11.6 equals 11.6, right? So I just wanted to point that out to you, that even if you like, it's going to be times when you check your work and you don't get the exact same values on each side of the equal sign. But if they close to each other, if they real close to each other, like these numbers are real close to each other. Like if this was money, this would be $11.61 rounded off, because the 8 would make the 0 go up and become a 1. Over here, this 4 would let the 0 chill and stay. So it'd be $11.61 versus $11.60. You're off by a penny. If you're off by a penny, you basically are dealing with the same amount of money. $11.61 versus $11.60, and it's due to a rounding difference, which started right there, all up in here with it, right? So this is a correct answer. X equals 0.2317. But it started with, now, I mean, obviously I knew how to do this, right? But a lot of times we be knowing how to do stuff, but we get all shook and intimidated because we look at a problem and it looks scary. It's like, oh, I see a variable in the exponent, and I see another number, and you know what I'm saying? Like we get all intimidated, and then we let the problem psych us out and knock us off our square, and we don't play our game, right? Calm down, have Imani, have faith, right? That you will get to the correct answer, and just go ahead and do your thing. Just go ahead and do your thing, just like I just did, right? Take it one step at a time, and sometimes, like if you forget, go back to your notes. Hopefully, when you're in class, you're taking good notes. Hopefully, if you're not taking good notes, I don't know what to tell you, but hopefully you're taking notes, and you know what I'm saying? You can get to the answer. All right. And before I forget, shout out to my alma mater, the national treasure, the Morgan State University. Yeah, where I got my bachelor's degree from back in 2003. Man, I feel old. That was a long time ago. 2003. Anyway, but yeah, yeah. Shout out to the National Treasure down in Baltimore, over east on the east side, where I was educated. And before that, went to a lot of summer programs there because I grew up in the community around Morgan State University. Went to summer programs, went to Saturday programs. You know, Morgan has been a fixture in my life. So shout out to Morgan State University. But again, Remember, Imani, which means faith, seventh day of Kwanzaa. Make sure you subscribe to the All This Math YouTube channel and check us out for all types of content from arithmetic all the way up through calculus. For now, it's been real. I've enjoyed creating this focused and targeted content around Kwanzaa, a holiday that I've been celebrating since I was a young buck, very very young. Um, yeah, yeah. But I'll see y'all in the next video. Peace.